In this tutorial, we are going to see how to delineate watershed, sub-watershed and river networks using ArcGIS Pro. So let's get started. So our main idea is to delineate a watershed. Followed by that will be delineating sub-watershed, and naturally, in order to delineate a watershed, we require a river network file. So we'll be also doing that. Now let's get started. And let us first start to add our DEM dataset. So move to the option add data. So use this browse option to browse for the data which you have saved in. So you can see here, this is my elevation data. Let me add it. You can have a view of the elevation data. This is nothing but the SRTM DEM 30-meter resolution. You can see the location. So in order to delineate a watershed, we just require a elevation data set. So you can see here, this is a form of raster data which has the elevation information about terrain's elevation information. It will be having, each pixels will be having a value that represents the height of the terrain. So if you just visually inspect this raster, and on the left hand side you can see some values. The highest value has been represented in white color and the lowest value has been represented in dark black color. So highest value is nothing but elevation, lowest is also specifying the least elevation. So this is the elevation range of this raster data set for the given terrain, and you can see the color scheme over here, starting from white to grayscale to black. This is a representation, symbolical representation of the terrain using white and black color. You can also change the color in order to have a proper visualization of your data set. So if you just click on here, you will be end up in the symbology section. Under symbology, you can choose the color schemes. So if you click on the color scheme, it will be showing the color scheme name. Just come down, you can find elevation. So you can see elevation 1, elevation 10 likewise. So I'm going to choose elevation 1, and now you can see, have a better look at the data. So the white color represents the highest elevation and the blue color represents the lowest elevation. In between colors you can find. So you can also change some more colors. For example, elevation 10, you can see the difference of the elevation of the given terrain. So you can see the lowest elevation has been represented in dark green color. Here you can see some rivers or streams will be flowing up over here in this regions. So the next step is we are going to project the data sets to projected coordinate system. Currently the data set is in geographic coordinate system. If you just right click and go on to the properties, you can find the raster's spatial reference. So move on to source and here click on spatial reference. You can see that it is currently in geographic coordinate system, so we are going to project it. So basically in geographic coordinate system, the units of measurement will be in decimal degrees. That is not appropriate for calculation, because we are going to process flow accumulation, then we are going to calculate flow direction, accumulation and river networks. Followed by that we are going to also calculate the area or length. So for that we require projected coordinate system. So now let us close it and just focus on projecting our layer to projected coordinate system. Spatial reference system from geographic to projected. So go to the option analysis, from there use tools. You can see the geoprocessing tools here. Just type in project and select project raster. Select it. Let us input the raster layer elevation dataset. You can choose the output location by using this option. You can browse and save your file. So I'm going to save it inside this folder. Let us rename it to project elevation. So right, we have given a name for it, and after that we are going to set the output coordinate system. So use this option to select the coordinate system. So from geographic coordinate system we are going to select projected coordinate system. So projected coordinate system, inside that UTM, and inside UTM you can see WGS 1984. So my area of study falls in northern hemisphere, so I am going to choose northern hemisphere. In northern hemisphere, my area of study falls in the following zone, that is zone 43. Right, now click on OK. If you have any confusion in selecting the zones for your area of study, you can use this website dmap.co.uk, and you can find your zone of interest, UTM zones. For example, in my case, you can see here my area of study is over here, and you can just check it. So it comes in 43 zone. So this tells about the zones, these numbers here, and at the top also you can find some numbers. Bottom also you can find the zones number, and you can easily distinguish between northern hemisphere and southern hemisphere. Till here it's northern hemisphere, and below that it is southern hemisphere. Below 0 is southern hemisphere, above 0 is northern hemisphere, right? So yes. Now after choosing the output coordinate system, we can just run the process. Click on run. So we have successfully projected our data, that you can check in by clicking on properties. In spatials, under source, you can see it in spatial reference. You can see now it has been changed to UTM zone 44N projected coordinate system, right? And you can also check the raster information. You can see now the cell size will be in meters, 30 meters, right? Now close it and let us begin the next process. So the next tool which we are going to use is fill sinks. So once again click on tools in analysis. Here type in fill sink. So you can find the tool fill. So click on it. Come down. You can see the fill tool inside hydrology. You can also use the toolbox and directly select the spatial analysis tool. Under that you can find hydrology, and inside that you can find the fill tool. So open this fill tool and let us input the projected elevation raster data, and you can save it to any particular location. So here I am going to name it as fill. Once done, click OK. So what this fill tool does is it removes the imperfections in raster data. Basically DEM data might be having some errors, like so if you see a raster data, you can see some errors like peaks and sinks. There might be a sudden rise in the elevation, or there will be a big drop in the elevation, which is called as sink. If there is a sudden rise in the elevation, it is called as peak. So that kind of errors will be removed. Why this needed to be removed is because when we are doing the flow direction, flow accumulation, that time if there is a sudden peak, the routing of the channel will not be perfectly done. So it is better to remove such errors. So now click on run to begin the process. So the fill operation has been successfully done, completed. So let us remove the previous data sets so that it won't be confusing us. Before that, I need to show one difference. So you can see the elevation data set which we have kept it earlier. You can see some elevation difference over here. After performing this fill, you can see this the raster data sets elevation has been updated. So previously you can see -14 value. Now you can see it is starting from 1030 to 0. So likewise some imperfections will be removed using the fill tool. So the next is we are going to calculate the flow direction tools. So inside toolbox you can see a lot of tools available. So inside that you can see spatial analysis tool. So within that you can find hydrology, right? In hydrology, next is we are going to calculate flow direction. So click on flow direction, and here we need to input our surface raster. Our surface raster is fill DEM data, right? And after that, you can see here you can give any name to the output. So I'm going to leave it to default. If you want, you can browse use this browse option to save it to any particular location. And you can see the flow direction types. So here 3 types has been there. So in this case we are going to use D8. If you want to know more about this algorithm, how it works, you can just click on this I button and you'll be getting to know more about this, what this D8 algorithm do. So this method assigns the flow direction to the steepest downslope neighbors. So you can have a view about this. The D8 for flow direction method, also known as 8 direction flow direction, is a common algorithm used in hydrology and spatial analysis to determine the direction of water flow across a surface represented by the digital elevation model. It works by assigning each cell in the DEM a direction that corresponds to the steepest down slope path. So you can see here 32, 64, 128, 1, 2, 4, 8, 16. These are nothing but the directions. For 64 is north, 128 is northeast, 1 is east. Likewise, you can just see the direction. So each value represents the direction. 2 southeast and 4 south, like this. 16 west. You can follow this. So basically this algorithm assigns the flow direction using this directional, and next it takes into account the steepest slope downflow. So for example, if you take this, you can see that you can see some values over here. This is nothing but the elevation values. So you can see the value 78. So from here where the water will be flowing, from 78 the steepest is 67. So automatically it will be flowing like this in this direction. So right, so like this it will be calculating the flow direction. So now let us move on. Geoprocessing tools. So now click on run to begin the process. So sometimes it might be taking some time based on our study area. So the flow direction has been successfully completed. As you can see here, you can see the values 1, 4, 1, 2, 4. This is nothing but the directions which I have already shown you in this from this image. These are nothing but the directions, right? So each value represents a direction. If you just zoom in, you can see the flow direction of this. You can see this is nothing but 16, right? 16 is towards east. Likewise, you can clearly see the flow direction of each cells. It will be assigned one color. This color is representing the direction, flow direction. So right, so the next step is we are going to calculate the flow accumulation. Once again, go to geoprocessing, go back. You can directly type at the top and search for your tools. Otherwise, you can come in this and find it, flow accumulation. So here we need to input our flow direction file. So I'm going to leave this as default, or you can also save it to any particular location. Now click on run. So you can see here we have successfully completed the flow accumulation, and you can just have a look at this raster values. You can see from 0 to this going, so this values goes in millions. So basically what this raster represents, so this represents the number of grid cells drained. So if you just zoom in and go to the pixel level, you can see the white color and black color. So normally the white color represents higher value of drained cells and black color represents the lower value of drained cells. So in order to check on this value, move to map and select explore. And if you just click on this on the white color, so if you just click on here, you can find the pixel values. So here the drained cell are very high. You can also see some difference. If you go to the upper stream or upper catchment, you can find a less number of, you can see it is very less, that is the drained cell is very less here compared to the downstream. You can check here. So you can see that the lowest flow accumulation is represented in black color and the highest is represented in white color. So in between you can see it will be there in grayscale. So this is nothing but the output is nothing but the river system or drainage networks. In order to properly visualize it, we are going to make some changes to it so that we can also see the tributaries. Right now we can just see the main channels. We can also see the tributaries by making few changes to the raster. So right click and you could see the option symbology, and in symbology you can see defaultly it will be there in stretched. So let us change it to classify, and instead of 5 classes we are going to go with 2 classes. So now you can see 2 values are there. In order to view the tributaries, we are going to reduce this value, as you can see here. Now currently it is 3,03,362. So I am going to reduce it to say 60,000, and now you can see some difference in that, right? So we are going to further reduce it up to, we are going to reduce it to 40,000. Sorry, 40,000. Now if you zoom in, you can find the tributaries also. You can clearly see the tributaries, and finally make it to 25,000. So this value you can put it accordingly based on your interest. So if you still want to see the further tributaries, you can reduce the values and get it accordingly. Now let us change the color. So you can see how it is. Right? So you can see here this is a small watershed, and I think it's better for me to reduce it to somewhere around 20,000. Right? Okay. So now after getting our tributaries correctly, so let me change it to no color. Or let us put it back to black color itself. So we just change it to make it as a transparent color. Right? Now if you zoom in, you can find the river. So the next step is we are going to add the outlets for this watershed. So you can see here this is my area of interest. So in order to delineate a watershed, we require the outlet points. So we are going to create a point layer. So let me go to the catalog, and here inside my folder I'm going to create a new layer. So click on new and shapefile. So let us give a name for it. outlet, and the geometry type will be point. So we are going to select the coordinate system. Geographic coordinates, we are going to use projected coordinates, UTM, WGS 1984, Northern Hemisphere. (43). Click on OK. Now once again click on run. So we have created the outlet. So outlet is important for delineating a watershed. As you can see here, if you take this river starting from here, and you can see it is joining the sea over here. So this is the outlet point of this river. So in order to delineate a watershed, we require outlets, right? So let us see. Now you can see create features, or you can use the option directly at the top after selecting this point, edit, and here you can choose create, then followed by select the point file, right? And after that, so let us set the outlet point for this river. So I'm going to place a point before this one. So this is the first outlet point, right? We have set the outlet point here, and if you just open the attribute table and check it, you can see that a point has been created, a record has been created. Previously there was no record, so by adding this point we have created a record, right? Now let us save it. So using this single point we are going to delineate a watershed. Followed by this we will be delineating multiple watershed or sub-watershed, right? So map, explore. So move to analysis tools once again, and this time we are going to use the watershed tool. So we are going to input the flow direction file, and followed by that we are going to select the outlet point which we have created. So that will be useful for delineating the watershed. And you can also see pour point ID. So pour point ID currently is not required. If you are delineating multiple watershed or sub-watershed, the time it will be required. So this is the output file name. You can change it, browse and change it to any destination you want. You can save it. Now let us click on run. Now you can see here we have delineated the watershed, view of the watershed. And if I just move this flow map to the top, you can see how it is looking. So like this you can generate the watershed. So we'll be seeing later on, we'll be seeing how to convert it into a polygon. From raster we are going to see how to convert it into a polygon. So once again geoprocessing, go back. So at the top just type in raster to polygon. So you can see the tool raster to polygon, open it and input other raster. So our input raster will be watershed flow 1, right? You can see just we need to check this one, simplify polygons. If you want, you can also customize the name, or you can choose the location where to save it. Watershed, click on OK and let us run it. Now we have successfully created the watershed. From raster we have converted it into a vector file also. So now let us see how to delineate sub-watershed. So let us uncheck the watershed boundary which we have converted from raster to vector. Right now we are going to focus on creating outlet points. So previously we have created only one outlet point for this watershed. This time we are going to create a multiple. So once again, what we are going to do is we are going to copy this and we are going to paste it here itself. So you can see here we have pasted the outlet points which we have already created. We had only one point, right? Now we are going to create multiple outlets. So I have renamed it as outlets, right? Now let us add it to the ArcGIS and let us remove the previous outlet. So now you can see here inside this only one record is there that we have created earlier for delineating the watershed. Now we are going to create multiple. Before that we are going to add a field. So I am going to name the field as value. So I am going to keep it in long and now save your edits. Once you have saved your edits, you can close the attribute table. Now let's start to put the outlets. So go on to edit and you can find create, select the outlets, right? Now in order to delineate a watershed, so now let us put outlets for each and every sub-watershed or catchments. So if you zoom in, you can see broadly two sub-watersheds are there, 1 and 2 here. So we are going to first, so I'm going to place the outlet over here, 1 point from the main stream. So after placing the first outlet, so I'm going to place the next outlet. I'm going to place it over here. So we have added 2 outlets and you can see this is the third outlet, right? So I'm just leaving on space in between, and this is the fourth outlet. So leave at least one space between the main channel, and finally you can see there is a sub-watershed, small one. So we are going to place it here. So we have placed few outlets across the watershed, right? Now after that we are going to save our edits. Let us open the attribute table, and now we just give a unique value for each outlet. So first I am going to select this one. You can see this is the first, that is which we have created at the beginning, main outlet. I am giving a value for it. So if you select it, it will be automatically highlighted in the maps. You can zoom and check it. So for this I am going to give value 2. So likewise I am going to set some unique values for each of the outlets. So you can see fortunately the FID is also having some values uniquely, but always try to create a separate field and make sure that values are always unique. So now after finishing, save your edits and close the attribute table. Clear all selection. Now once again move on to geoprocessing, and here at the top once again search for watershed, spatial analysis tool, click on it. Here we are going to input our flow direction, and after that we are going to choose the outlets. So after selecting the outlets points which you have created, you can see the values. So this is the unique, each outlet values has a unique value. So I'm going to choose this field. You can save the output sub-watershed raster. You can browse and save it to any location. So the output is a raster file. Click on OK and let us click run to begin the process. So now you can see here we have successfully delineated the watershed. So if I bring the flow accumulation raster to the top, you can now see we have successfully delineated our watershed. Now you can convert this sub-watershed to an vector layer. Geoprocessing. Here once again use raster to vector. Raster to polygon. Click on this tool. Input the raster, sub-watershed, and field will be value. And you can use this option to save it to a particular location. So I'm going to name it sub-watershed. So click on OK. Simplify polygon. Run. So you can see here multiple watersheds has been generated. You can open the attribute table. You can see the grid codes. So if you click on each of this, it will be highlighted accordingly, right? So if you are interested to calculate the area, please add a field, and here in the field name, let us set a field name for it, area, and here instead of long I am going to choose double. In numeric, click here, once again select numeric. You can specify the decimal degrees, decimal places. So I'm going to give 3. Click on OK and save your edits. Once you have saved your edits, after closing it, you can see a new field has been created. Now select this field, right? After selecting this field, right click and you can see calculate geometry. Click on it. So here we are going to select the sub-watershed file. Defaultly it is selected, and so we are going to select the field for attribute field. So area, as we created here, separate attribute field, and you can see the properties. So in the properties also we are going to select area. So defaultly if you have selected any features here, you will be getting option like this. Use the selected. You can only calculate. You can also calculate area for a single watershed also by selecting it and by turning on this option. Otherwise you can turn it off, right? So now you can calculate the area. So you can see here the area units. You can choose any units from here. I'm going to choose square kilometers, and after that we are going to choose the coordinate system. So I'm going to use projected coordinate system, UTM, WGS 1984, Northern Hemisphere, Zone 43. So this is the UTM for this location. Now click on Apply and click OK. Now you can see here we have calculated the area for the sub-watershed also. So now let us see how to save this river network and how to convert it from raster to vector layer. So go to this geoprocessing tool and here type in reclassify. So reclassify spatial analysis tool. Open this tool and let us input our raster file, flow accumulation, that is the raster file. After choosing the values, here you can set the new value. So from 0 to 20,000 I am going to set it 0, and 20,000 to 11 lakhs I am going to set 1. Now let us click on run. So now you can see here we have successfully converted, that is, we have successfully reclassified it, and now the final step is we are going to convert it into a vector layer. So use raster to polyline. Just type in raster to polyline. Conversion tool, raster to polyline. So our input file will be reclassified, and you can see value, field is value, and you could save it to particular location. So I'm going to save it as river network, or you can also save it as network river. So click on OK, and here in the background values please select 0 as the background value, and click on run to begin the process. So once you have done it, you can see how it is looking like. Now it has been successfully converted into a vector layer. You can clip it using your watershed boundary. So we have already created the watershed boundary first, right? So we can clip it using that geoprocessing tool. Here just type in clip, analysis tool, clip, input is our river network, and clip feature will be our watershed boundary. You can save it to any particular location by using this option, browse. Just click on run to begin the process, and you can see here for our watershed alone we have got the results. Now you can see here how it is looking like. So you can click on the sub-watershed and you can go to symbology. So instead of single color you can go for unique values, and based on the grid code you can assign colors to each of them like this. You can change the color ramps also. Like this you can give any color scheme to it accordingly. And you can also change the colors for your rivers also. So just double click here, you can see you can set colors accordingly, right? Here itself you can type in river and hit enter. So you can see here you can prepare like this, wavery, zigzag. So likewise you can do. So you can select the sub-watershed feature layer, you can reduce the transparency. Deselect this sub-watershed, come down. So you could add your elevation data set, and once again let us increase the transparency. As you can see here. So like this you can do delineate the watershed. If you have any other doubts on this, please do ask in the comment section. I will be answering to your questions. If you like the video, please do give a like and subscribe to the channel. Thanks for watching.